Sorry we got interrupted there. Here's a picture. If the box represents the set of all possible committees, and if A represents the number of committees with less than or equal to 8, members, then A prime represents the committees with more than 8 members, which is the number of committees with either 9 members or 10 members. If you think back to set theory, you know that if you have 10 people and you want to choose committees, there are 2 to the 10th possible committees that can be chosen, because there are 2 to the 10th possible subsets of a 10-element subset. The number of subsets of a set consisting of n elements is 2 to the n. So this total number of possible committees here is going to be 2 to the 10th. The number of committees that have 9 people would be the number of combinations of 9 people out of 10. Actually, there would only be 10 such committees. That's what this combination will come out being equal to, because there are 10 people and one person's got to be excluded to make a committee with 9 people. Since there are 10 possible people you can exclude, there are 10 possible committees. So that the number with 9 is C of 10, 9, and the number with 10, of course, is C of 10, 10. Of course, the only committee that has all 10 people is the set consisting of all 10 people. In any case, this is going to end up as 2 to the n minus C of 10, 9 minus the quantity C of 10, 9 plus C of 10, 10 and we don't want to write n there, that's actually 10, so it'll be 2 to the 10th minus this. 2 to the 10th you can easily calculate as 1024. C of 10, 9 is easily found to be 10, and C of 10, 1 is 1. So we have 1024 minus 11. The 1024 possible committees minus the 11 that have either 8 or 9 members. Now we could have calculated this easily enough, but it would have been somewhat tedious. We could have said, well, let's see, we could add the number of 0-member committees to the number of 1-member committees to the number of 2-member committees, and so on until we get up to C of 10, 8. That would have solved the problem also, because we would have had the number of 0, 1, 2, 3, 4, 5, 6, 7, and 8-member committees. And we could have calculated that, and had we done so, we would still have come off with the same number, 1013. So we've illustrated here the principle that the number in some set A is the number in what we'll call the universal set, and that should have been a lowercase n, minus the number in A prime, the complement set. Of course, we're assuming that you know about sets and set complements if you're in the second semester of this course. If you don't, and the first semester isn't officially a prerequisite for the second, and really these chapters are pretty independent. This is one of the few things that really kind of depends on what we learn in set theory. You can go back and look at numbers of subsets in chapter 2, or you can simply accept the fact that there are 2 to the n possible subsets of a set of 10 objects.